to using ZFS to create a file share, you want to identify the disks that you have. And one thing to remember with ZFS is that if you actually use the whole disk for a ZFS pool, or use whole disks as part of that pool, then the write cache is enabled by default. And so you'll get some performance gains from that. And like I was saying before, the guarantees that you have with ZFS mean that you'll still be on disk consistent. So ZFS has a good way of guaranteeing that. They essentially will load these things up into transaction groups, and when the transaction group is being written, or at least the last element of that transaction group is being written, then the write cache is flush. It means that if you fail at some point during that transaction group, you're still able to recover the state of the system as it was before. I mean, there are a lot of details to it, but essentially they have a series of blocks that refer to these groups, and they can go back to the last consistent state. And this is where copy and write is a fundamental win in an operating system technology, or at least a file system technology. So anyway, enough of that segue. So now I've identified my disks. What am I going to do? So you want to create a pool. So when you create a pool, that essentially is analogous to the way that you would create a volume with a typical volume manager. And on top of that, you can then create a file system. Now, again, you may well all be familiar with ZFS. One of the nice things about ZFS is that you don't go and say, oh, well, I need to create a file system that is this big. You can certainly prevent it from growing larger than a particular size, but it'll essentially dynamically grow with the use of that file system. So you could go away and create 1,000 file systems on this pool, and you wouldn't have to divide that pool up into little slivers for each of those file systems. You could let them grow as the use dictates. Okay. So moving on. So it's obviously not very interesting to just create a file system. If you have a NAS box you want to create, clearly you're not going to treat your storage as direct attached storage. So you need some kind of protocol that allows you to talk to this box. So the most standard way that we in the Unix world talk to a box over the network is using NFS. And if you have a look at these steps, it's pretty clear that it's very simple to create a NFS share using ZFS. Essentially, there's a property of the file system. You just flip the bit and you're done. So, I mean, the first two steps are more just bookkeeping, really. Really, if you have a look at this, ZFS set share NFS equals on my/myfs. I've gone and played with export FS, a lot of these export tabs, all of these things, and this is clearly a very simple phraseology for creating an NFS share. So the last step, and again, I'm sure you're all familiar with how to mount an NFS file system. This is more for completeness. So let's see. So we've been talking about COMSTAR. And how does COMSTAR fit into this picture? I think COMSTAR is where we add breadth to the storage technology here. It's all well and good to create an NFS file system, a file server, or a CIFS file server, but we all know how to do that today. That's not really a significant win. What is a significant win is to be able to sort of beat out some of the legacy technology that you might have in your data center today. So it may be that you're spending a lot of money on fiber channel disk arrays. It may be that you're spending money on SAS disk arrays, or you will be soon. Or you might be looking at migrating to iSCSI or fiber channel over Ethernet, because you don't really want to have multiple networking technologies in your data center. COMSTAR gives you the ability to support all of these things, and you can support all of these things inside of a single server box. That's really powerful. It really is. It gives you the ability to not be tied into a specific vendor for where you get your disk arrays. You can go to the cheapest server vendor or the cheapest cost per gigabyte of your server plus storage vendor. So anyway, what I've got here is some of the steps that we have for taking what is a fairly standard Open Solaris install server and turning it into a fiber channel target. So the first steps that I'm sort of going through is essentially talking about installing COMSTAR. Actually, I left out the part where you install the package, but the packages are all available from the Open Solaris website, and we just actually integrated into Solaris last week, I think. So this will be coming as part of the later Open Solaris drops. So the first bit that we talk about here is if you have a server and you want to make a fiber channel target, already there's a fiber channel driver that would be attached to that in initiator mode. So we have to convert that to say, hey, actually, we want this HBA to be a target. So what this first step is talking about is how do we go and identify what HBA is in the fiber channel initiator mode. And we need to, the second step is going, well, now that we have identified this HBA and we want to turn this HBA into a target, let's go and convert it to use the QLT driver. And so T clearly in that case stands for target, so it's nice and easy. So we go through, we associate it with that, and down the bottom you can sort of see the differences between the two MDB output streams. And so now we've converted it into a target mode. What can we do with that? So first of all, let's make sure we enable the COMSTAR service, or the SCSI target mode framework. So again, this is all managed through SMF, which is another very cool thing about Solaris technology. Once we've done that, we want to make sure that the framework can actually see the ports that we've identified to be in the target mode, and we can run that string there. That will give us a pretty good idea of what's going on with that. So, these next steps are more for sort of illustration about how we would go away and do it in the thin provisioning case. And if you remember, earlier we talked about the other back installs that we could have for COMSTAR. Again, it could be a ZBOL, it could be a ZFS file system, it can be memory, or it can be a raw disk. So this is merely one example of the way that you would go away and do this. So we're creating a thinly provisioned SCSI logical unit, and we just do that by touching the file, and then the SPD ADM command is here for sort of saying how big do we expect this lung to be. And you don't necessarily actually have to have that amount of space available. In fact, I believe that in development, we've created a multiple exabyte thinly provisioned node. And so what you can do is you can create this large lung and just add the storage to it as necessary, but you don't necessarily have to have it all there to begin with, and you can just be a little bit more dynamic in the way that you address those needs. So